Okay, we're going to take a look at number 12 from D2. The directions on this section here say to find the tangent line equation of the curve at the given point. So we have to find a tangent line equation. Anytime you need to find a tangent line, you need two things. You need a point, which is two numbers, an x and a y, and a slope, which comes from a derivative, whether it's an f prime or a dy dx. Whatever the derivative is in your problem, that's what you're going to use to figure out the slope. So we have part of our point. We want the point where x equals square root of 3 over 8, but we don't know the y value at that point. So let's start out there with the point. Oop, eraser on. We need to plug in that root 3 over 8 into our function. So we'll do cosine inverse of 4 times root 3 over 8. Which is going to give us, basically the 4/8 is going to cancel to a half. That's just going to be the cosine, or the inverse cosine of root 3 over 2. You know, the thing about these inverse sine, cosine, tangent problems is I've got to give you a unit circle value or the problem needs to be calculator active. So when you see x equals root 3 over 8, that's not a unit circle value, but the argument being 4x turns it into a unit circle value. So that should happen, and if that doesn't happen, you should be kind of scratching your head and saying, what's going on here? Did I miss something? But that's what's going on. So we're really looking for the angle that gives us a cosine of root 3 over 2. So I will sketch a quick first quadrant of the unit circle. If your input is positive, no matter which function it is, you're always going for the first quadrant. If your input is negative, then depending on whether you're sine, cosine, or tangent, those are different quadrants. We do have that highlighted from the notes in class. Cosine uses quadrant 4, but it uses negative x values, or negative angle values, I should say. And sine and tangent use quadrant. I'm sorry, I think I said that backwards. Sorry, sine and tangent use quadrant 4 when they're negative. But we don't have an example like that. And let's see, are any of them? Yeah, you'll definitely need to think about that when you try number 14. Okay. So that being said, let's take a look here. We have our unit circle. We want to find root 3 over 2. So I'm going to label this 1, 0. I'm going to label this 0, 1. We've got 3 lines here, 1, 2, 3. And our answer is the angle value for one of those lines. We want arc cosine, so we can go ahead and we're only thinking about the x values. So when I go to write my points, I only need to put the x values there for right now. So we count up from 0. So we're counting from the top down, 1/2, comma, root 2 over 2, comma, and then our third line is what we're looking for, which is root 3 over 2. I wrote that a little bit big. Got excited because it was what we were looking for. Let's clean that up a little bit. Our third one is the root 3 over 2, comma. Okay. And then obviously the x values the y values, which are for inverse sine, go in the opposite order, but these are all we need. And that's enough to tell us that we need the bottom line, and the bottom line is pi over 6. So the inverse cosine of root 3 over 2 is pi over 6. So that means that our point is root 3 over 8, comma, pi over 6. And we have 2 of the 3 numbers that we need for our tangent line. All right. So there's our point. Slope, we need a derivative. So we'll write out slope here. We need dy dx. Basically, we've got kind of 2 things going on here. We've got inverse cosine, so we've got to take the rule for sine, but make it negative. We have an argument of 4x, which means we need to use the chain rule or the linear chain rule. They both tell you to do the same thing. And that same thing is to multiply the whole thing by a 4. So with these inverse trig derivatives, they all have a 1 over in their numerator. So you can always just put whatever the chain rule tells you to do right in the numerator. Because multiplying the whole thing by 4 is the same as multiplying the numerator by 4. And, 4 times 1 is just 4. So the linear chain rule tells us to put 4 here. The fact that it's inverse cosine tells us to make that 4 negative. And then the denominator is the same regardless of whether you're sine or cosine. It is the square root of 1 minus the argument squared. So that's going to be 1 minus 4x. But then that argument, the whole thing, is squared. So that is our derivative. All we need to do is evaluate our derivative at the point x equals square root of 3 over 8. And that's still going to give us negative 4 in our numerator. In our denominator, we are going to get the square root of 1 minus. Now, don't do repeat calculations. We had to do 4x before. Sorry, I'm nice and straight. Back in cosine inverse, here we did 4x and got root 3 over 2. So 4x is still root 3 over 2. So I'm just going to say root 3 over 2, but squared. On an FRQ, that is a perfectly good slope. Honestly, there aren't a ton of, I can't think of an FRQ that I've seen that has inverse cosine in it. So these are usually multiple choice questions. So let's simplify this. We would end up with negative 4 over the square root of 1 minus. And as far as squaring this fraction right here, as long as it's just a number numerator over a number denominator, you could square both of those separately. The square root of the square root of 3 is 3. And the square root of 2, or sorry, my bad. The square root of I keep saying square root and I don't want to. The square root of 3 squared, which is what I'm trying to say, is just 3. And then 2 squared is 4. And we end up with negative 4 over, we have 1 minus 3/4, and 1 minus 3/4 is just the square root of 1/4. Okay. But the square root, when you have like a unit fraction like that, 1 over a perfect square, that's easy to find the square root of. This is just negative 4 over 1/2. If the square root of 4 is 2, the square root of 1/4 is 1/2. It kind of works the same. So we've got a master fraction here, 4 over 1/2, negative 4 over 1/2. That is negative 4 times 2 over 1. Our slope is negative 8. It's a nice whole number there. Finally, we can write our tangent line equation. We have everything we need. Y equals negative 8 times the quantity x minus our x value, which is root 3 over 8. And then we're going to plus pi over 6. Cool. All right. The only thing we have left to do is to jump into Desmos and check this. So we'll go ahead and do that. Desmos. Our function is f of x is cosine inverse. So we'll do cosine. Not sure if this works. Can I say negative 1? Oop. Am I allowed to type negative 1 in here and have this work out? We're about to find out. Yep, that is the inverse cosine function. That is correct. And our tangent line is y equals, but it was cosine 4x, right? There's our correct function. Let's fill up our screen there. And we ended up with y equals negative 8, the quantity x minus square root of 3 over 8, right? 3, got to get out of that to divide by 8. And then plus pi over 6. Something's off. Pi over 6. Oh, no, something isn't off. I just didn't think that was going to work out that way. Okay, perfect. Yeah, and we do have, that is what I expect to see with the tangent line. It touches it at one spot, and that one spot is the decimal versions of root 3 over 8 and pi over 6. If you guys take a look at my answer key for this, I checked all 4 of these in Desmos. I want to make sure that I'm right. I want to know that I'm right so that I know what I'm doing. And when I'm saying I there, I'm meaning you. You want to do that. Instead of, if you can troubleshoot any mistakes that you made, hopefully, and then get the right answer. Okay, if you've watched the video this far, you now have number 12 done. Go ahead and Yeah, take a look at the other ones. Number 11 is relatively straightforward because the argument is x. Oh, I'm like showing you guys my answers. That's awful. But I'm posting my answers online anyway. So anyway, yeah, just be really careful with number 13 and number 14 because they have different arguments. But if you follow those steps, you should get the right derivative each and every time. I'm going to post these online anyway. I believe I may have cut back on some of the problems, so you may you have less problems here, but all of the problems that you do have to do are somewhere on here. So as you get to the end, I believe 18 and 19 are different. I think 19 is one of these three problems because I cut some out that just kind of didn't make sense. Okay, all right, so there we go.